Let's see what we came up with. Well, this person did a lot of work. Okay, so they filled in this missing angle here of 45 degrees. Okay, that should be the easy step, right? Because if this is 90 and this is 45, this third angle has to also be 45 degrees. 45 degrees, 45 degrees. Okay, so now we'll take a look at the work that we came up with here. So someone wrote down that 18 is equal to question mark times the square root of 2. Okay, and question mark is this missing leg length. And we know these two legs are going to be the same length. This is what we learned earlier this week in an isosceles right triangle. There's a special relationship. Okay, so the leg lengths are the same measure. They are congruent. And the hypotenuse is square root of 2 times as long as each leg. So if the leg length is x, then the hypotenuse is x times the square root of 2. And so that's what this person was doing here. They're showing it as multiplying this unknown by the square root of 2 is equal to 18. And then they're dividing both sides by the square root of 2. And at this point here, they know they shouldn't leave a radical symbol in the denominator. So this is called rationalizing your denominator. So to get rid of this radical, we multiply by the same radical, square root of 2 times the square root of 2. But then you also need to multiply the numerator by the square root of 2, so you're not changing the value of your answer, because we're really just multiplying by 1 when we multiply by the square root of 2 over the square root of 2. Square root of 2 times the square root of 2 is 2. 18 times the square root of 2. Okay, and then they realize, hey, 18 and 2, well, I could divide 2 into 18 and get 9. So they did a really nice job here showing their steps. This is nice. 9 square root of 2 is correct. This person also got 9 square root of 2. Good work. 9 square root of 2 again. Nice job. Okay, so that is the correct work for the warm-up. And so today, our lesson is going to be on a different kind of triangle. So we were looking at isosceles right triangles, or a 45, 45, 90 triangle on Monday and Tuesday. But today we're looking at a different kind. And this is called a 30, 60, 90 triangle. And there is also a special relationship with these types of triangles. And so your learning goal today is I can use special right triangle relationships to solve for missing side lengths. Good morning, Jocelyn, Misty, Marissa. Hi, Nathaniel. Hi, Fernando. Hi, Oziel. Carmen, welcome. Okay, so we have our vocabulary for today. A 30, 60, 90 triangle is a right triangle that has a special relationship amongst its side lengths. The hypotenuse is twice as long as the shorter leg. And the longer leg is square root of 3 times as long as the shorter leg. So the relationship here is a little more complicated because before we had the 2 legs that were the same and the hypotenuse. But here, all 3 sides are different, but there's a relationship amongst those 3 sides. So if you know you have a 30, 60, 90 triangle and you have at least one side length, you can use this relationship to figure out those missing side lengths. And so in this diagram here, they're starting with this shorter leg at the bottom as just being x. So whatever this value is here, if I multiply it by 2, I get the hypotenuse. The hypotenuse is exactly 2 times the length of the shorter leg. The shorter leg is the one that connects the 90 and 60 degree angle. And then the relationship here, this longer leg, the side of the triangle that connects the 90 degree to the 30 degree angle, is exactly square root of 3 times the shorter leg. So if you know any one of these, you can figure out the other two using either multiplication or division. And that's what we're going to do today. We're going to solve a right triangle that is a 30, 60, 90 triangle. Okay, so this is the problem we're going to work out together. This is our example. And so we're going to find the unknown side lengths. We can see this triangle EDF has a 60-degree angle, a 90-degree angle, and we have this measurement here of 10 times the square root of 3. So when you are given a triangle that's a right triangle, it may be that you have a special relationship amongst the side lengths. And so what we're going to do here is just go ahead and start by labeling what the sides are. So right here, I put a blue line across 10 square root of 3. And this side of the right triangle is, in fact, this is the hypotenuse. Okay, we know it's the hypotenuse because it is across from the 90-degree angle. It's across from it, makes it the hypotenuse. And then we have two legs that make up the 90-degree angle. Okay, and one will be shorter and longer because of the measures of the angles. If these were both 45 degrees as my acute angles, then the two legs would be the same length. But because one of these is 60 and this is 90, I know this missing angle here must be 30. So I'm actually going to fill that in too as we're doing this. So that's 30 degrees. So we can write some facts down here. We know the three angles of any triangle will always add to 180 degrees. Let's see, we know the hypotenuse is across from the right angle. We know the legs make the right angle. Okay, and of those two legs, we have ED here, and we have DF. Okay, these legs are going to be different lengths because it's a 30, 60, 90 triangle. One is shorter and one is longer, and so we could label them as such. This one's the shorter leg. And I have the longer leg. Okay. Let's see, we also know that we know we have a 30, 60, 90 triangle, which gives us a set relationship between the side lengths. All right, so lots of stuff we know. Just adding that all in for you. You can type that on yours or put it in your notes. Hi, Garen, welcome. Hi, Alicia. Okay, so we're gonna figure out, because we already know the hypotenuse, we're gonna figure out the shorter and the longer legs. And so what we wanna do is look at what the relationship is. So it says that the hypotenuse is twice as long as the shorter leg. So we're going to start with that. The hypotenuse is twice as long as the shorter leg. And so our hypotenuse is EF, right? And it's equal to 10 square root of 3. And so the shorter leg is ED. So EF is equal to 2 times ED. So that is one relationship that we know is true because it's a 30, 60, 90 triangle. The hypotenuse is exactly twice as long as the shorter leg. And so we're just going to substitute in the value of the hypotenuse, which is 10 square root of 3 for ED. And now we're going to figure out ED just by solving this equation. 2 and ED are being multiplied together. So we're going to do the opposite. We're going to divide both sides by 2. Two divided by 2 is 1. 10 divided by 2 is going to give me 5. So 5 square root of 3 is equal to ED. And so now I know that the shorter leg is 5 square root of 3, and I could write that on my triangle and show it too. Now, if we were doing the other type of triangle, we'd already be done because we do that. The 2 legs are the same length, but here that's not the case. These 2 legs are different lengths. And to get the length of the longer leg, well, we have to see what the relationship is on this 30, 60, 90 triangle. So if I come back to this slide, it says here that the longer leg is square root of 3 times as long as the shorter leg. Okay, we now know the shorter leg. The shorter leg is 5 square root of 3. The shorter leg is ED, and the longer leg is DF, but it is unknown at this time. So DF is going to be exactly square root of 3 times as long as the shorter leg. So we have DF is equal to square root of 3 times the shorter leg, which is ED. And then we're going to substitute in what we know about the shorter leg, that it is 5 square root of 3. And so DF is isolated on the left, and on the right-hand side, we just have a product of some things going on. Square root of 3 times 5 times the square root of 3. Well, the square root of 3 times the square root of 3 is 3. And so we're ending up here with 3 times 5. And we can simplify that one more time to 15. So now I know that DF is in fact 15. Do you guys have questions about this problem and how we set this up? So I'm not seeing any questions pop up. So we all kind of understand what was going on here. So you're going to try to do one of these. The next slide that you're going to try is slide 5. Okay, again, you have a right triangle. And we can see that the two angles that are acute are 30 and 60. So this is a 30, 60, 90 triangle. And we are given one side length. We are given 4 square root of 3, which happens to be the hypotenuse. So this is a very similar problem that we just did together. We were given a 30, 60, 90 triangle and given the hypotenuse. So you're going to go through the same steps and you're going to solve for the unknown side lengths on slide 5. I'm going to leave my screen here on slide 4. As you work on slide 5, I'll give you feedback through the Pear Deck.